So hello everyone and a warm welcome to our third international webinar. It is a great pleasure to have you all here with us today. My name is Silvia and I will briefly guide you through the instructions of today's webinar. The webinar will last about 1 hour and there will be two presentations. You see already our two speakers connected. Each presentation will last about 20 minutes. There will be a short Q&A session at the end of each presentation, and there will be a final debate at the end of the webinar. For this purpose, you may ask questions and make comments at any time. Please, they are very welcome and very important for this webinar, so use the box on your right. It is the question box, and we will read your questions, and the speakers will give them an answer after their presentations. If there is not enough time for all the questions, the speakers will be available afterwards. You will receive their presentations, the video recording, and they will be available via email. So now, without wasting any of your time, I would like to pass the word to our Director General of Centro Studi Galileo, Marco Boni, who will be the moderator of this webinar. Let me just introduce the speakers. The first speaker will be Ernesto Revello, Sales and Business Development Manager for Opteon Refrigerants from the Chemours company. He will present us the main differentiating factors of A2Ls versus A3s and other technologies. Second, but not for an important reason, there will be Paolo Mattavelli, R&D Manager for Errecom, who will talk about new refrigerants, lubricants, and additives evolution to grant top performance of HVACR systems. So thank you all for your attention and please enjoy your webinar.
Thank you very much, Silvia. I hope you can hear me well. So, yes. Very good. Thank you, Silvia. Good morning, Ernesto. Good morning, Paolo. Hello.
Good morning.
Good morning, everybody. So I will speak first, giving an introduction, and then I will leave the word to Ernesto and then Paolo. So let me just give you a small introduction. I put your cam off and see you in a bit. So welcome everybody again, and I hope that all of you are well, which is the most important. It's important in this time of the year that all you are well. So welcome to this webinar today. I am Marco Buoni, Director of Centro Studi Galileo and President of AREA. AREA is an association of 26 national associations of Europe. We are from 22 European countries, and our Italian association is ATF. I will go quick on this one. We do training, it's our main job. We do training in Italy and in 130 countries with the United Nations, with agencies of UNEP, UNIDO, UNDP, also with European Commission. We did training all around the globe. For example, we had around 10,000 technicians trained and certified in the last 10 years. Also, we do webinars. As you know, we have a channel, YouTube channel, Centro Studi Galileo channel, where you can find all the webinars we have done till now, and also there is one that is from today. Also, we were one of the promoters of the World Refrigeration Day. Since the beginning, when we started, we were some of the promoter and one of the organizers of the World Refrigeration Day. So we enjoyed it a lot. The World Refrigeration Day we have organized the 26th of June 2020. And the speaker of today were present in this important webinar. Also, we do conferences. The next conference will be in Milan. We hope to see you in person, not virtually like now we are used to. We'll be in the 19th European Conference, and the registration is now open. It is the last conference was very successful. We had 300 delegates from 32 countries, 4 continents, and we had the European Union, European Commission, United Nations, the most important worldwide association from America, Japan, Europe, of course, and of course AREA, my association. Also, we are editor of a magazine, of a European English international magazine, International Special Issues, and also an Italian magazine, which is edited every month. I would like also to mention you Real Alternatives, because it's part of the webinar of today. Real Alternatives is a training about alternative refrigerants, which means we speak about flammable refrigerants like A2L, HFOs, A3, all kinds of refrigerants, carbon dioxide, ammonia, and we teach the theoretical part, but also the most important one, that is the best practice with alternative refrigerant, because we know that we need adding some skills using this kind of refrigerant, because we have to be very careful about the toxicity, for example, ammonia, the different characteristic of carbon dioxide, and of course the flammability. So we have to be very careful to use the right equipment, the right tools, and for this reason we have developed the ARA guide. AREA developed a guide, which is this one, and we have a guide about the differences between traditional refrigerants and flammable refrigerants. For example, we need a special recovery machine for A2L refrigerant. We need a special leak detector for alternative refrigerant. The vacuum pump, if it's a new generation, can be the same, but we have to be very careful about having the right space around the vacuum pump, and to avoid the concentration of flammable refrigerants while we are doing vacuum and our usual activities, recovery, charging, and also transport. Well, of course, we need the right ventilation in the transport, but also during servicing, we need the right ventilation. A2L, we know, are lower flammability refrigerants with a maximum burning velocity of 10 centimeters per second. And our colleagues later today will tell you more about it. Following a few but important safety precautions, we can handle them as traditional A1 refrigerant. But I told you earlier, few tools need to be updated, and we need to be a bit more careful, and we need skills. We need to have proper equipment, competent refrigeration service engineers, which is always the case. Also for A1 refrigerants, we need skills and competent and certified technicians. And with the Real Alternatives, we also certified all the technicians that are going to use also every kind of refrigerant. The important part today is to avoid the main danger, that is pooling, which means creating a temporary flammable zone when the refrigerant leaks, because the refrigerant is heavier than air and can gather in smaller spaces. So we have to be careful that high energy spark is not in such area. This is my message for today. So my conclusion are thanks to our partners, the Platinum, the partner, and the Silvers. It's very important to remind that they help us to be here to organize these webinars. And they give us the latest technical information about the latest technologies available in this time. And it's important that we are here today in a webinar, not together, not in person, but at distance. We know why, but we have this benefit, this important opportunity to be informed, to be knowledgeable, to have the latest development again here. Thank you, all of them, for being here. So now my presentation is over. Now we have 60, nearly 70 participants online. So my presentation was also to let everybody speaking. So I call Ernesto now to come on board. Hello, Ernesto, again. I can see you very well. And I will put you presenter so you can share your slide. You can see probably in your screen, share screen. Yes, you can. And in a few seconds, we are going to see your screen. Yes, we can. Thank you very much, Ernesto, for being here with us. Thank you, Chemours. And please give us the latest information about A2L and the differences between A2L and A3 and other technologies and the main factors. Thank you, Ernesto.
Thank you very much, Mr. Buoni, for your introduction. And first of all, I would like to thank you, Centro Studi Galileo, for organizing this webinar and let us participate to this. So, as said, today we are going to speak about the main differentiating factors of A2L refrigerants in comparison with A3s and other technologies. Here you can see in this slide my details, my contact details, if you need to have further information in the future after the presentation. So let me start with an introduction of the agenda. We will start with an introduction speaking about the refrigeration industry and the concept of energy efficiency. Then we will analyze the phase down and the new Opteon XL products portfolio, and then we'll go deep into the core of the presentation, which is the safety risk mitigation, comparing A2L refrigerants versus A3s. Then we'll speak about also the EN 378 regulation and how to calculate the refrigerant charge size. And at the end of the presentation, we will speak about two others very important factors, which are the economical and environmental efficiency for commercial refrigeration, and we will present also some successful application with real case studies. So starting with the introduction of the refrigeration industry, I would like to present you this study made in the US, just to let you know how this industry is important and which demand is even set to grow in the next years. So you can see that is right behind the digital games market, for example, with an expected revenue of $135 billion in the US. The main and most important challenge we have nowadays, and you can see from the graph, is that more or less 78 of the greenhouse gases emissions, considered as CO2 equivalents, are related to energy consumption. The rest is more or less equally divided into industrial processes, agricultural, and waste. While to achieve the most important target that the European Commission have by 2015, which is reaching the climate neutrality, we need to tackle energy as a priority and energy consumption. Here we can see a better deep inside the energy consumption itself in the European Union. You can see that more or less half of the energy consumption is related to heating and cooling with a 47%, while the rest is more or less equally divided into transport with 28% and electricity with 25%. And in the bottom part, you can see even the percentage of renewable energies contributing to this energy consumption, which is still a bit low. And then it's important to introduce right now the TIWI concept. So this considers the total emissions, not only the direct emissions of the refrigerant, for example, connected to the GWP, while in the formula you can see that the last part is considering the impact of energy consumption, the annual energy consumption of the systems. And in the right graphs, and the bottom one, which is related to the European Union, you can see that as a contributing to greenhouse gas emissions, CO2 has an average of at least more than 80% contributing to this kind of emissions. While if we consider the HFCs, you can see that it's only related to 2.5%, more or less. So with the F-gas regulation, we are tackling this small 2.5%, while we need to consider and start considering with the TIWI concept the rest of the emissions, which are mainly due to CO2. Going deep into the phase down, you all probably know that we are running with the F-gas regulation right now in Europe, which is based on a quota allocated to importers and producers of HFCs in order to achieve by 2030 a reduction of at least 79% of the use of these refrigerants. We also show in the graph here in the slide 3 different average, which is the main GWP average in 2017 of 1,900. In 2021, which is next year, we forecast an average of GWP of 900, which is the global potential impact of the refrigerants sold on the market. And in 2030, we forecast an average GWP of the refrigerants of about 400. So you can see that the orange one are the commonly used refrigerant HFCs like 404A, 410A for AC and heat pump, or 134A, while in blue we are showing you our alternative refrigerant, Opteon XP series, for retrofit or new system with a lower GWP. But if you want to consider really long-term solutions, then we need to move down in the graph with the green solutions that we are providing as Chemours, which are the Opteon XL series. You can see that if we consider in 2030 an average of GWP of 400, in most of the cases, these refrigerants are far below this average level. For example, the XL20 for commercial refrigeration has an average GWP, has a GWP of 146, while the Opteon XL10 a GWP less than 1. So these are considered for us the real new alternatives, long-term alternatives, which are A12s. So they are considered as mildly flammable refrigerant, and we will speak later on about the characteristics of these refrigerants. So safety risk mitigation. If we start comparing A12s versus A3s, we need to start with introducing all the code and standards that regulate the refrigerant. So if we consider in Europe the refrigerant classification, we are following the ISO 817, while if we move to the safety of the refrigerants, we are following the general rule EN 378 in Europe. If we go deep inside the ISO 817, you can clearly see that there's a proper classification, a new classification that has been introduced for A12 refrigerant, which are considered as mildly flammable. This includes the series that the green ones that I presented you before, so the Opteon XL series, including YF and XL20. And the most important characteristics that is differentiating these refrigerants from the flammable and highly flammable ones as propane, which is an A3, is the flame propagation. So this means it should be less than 10 centimeters per second. Then in the right part of the graph, you see there's a column considering high toxic refrigerant, which are identified by the letter B. In this case, you can see, for example, ammonia is considered as a B12, so it's mildly flammable and highly toxic. But if we want to show you the characteristics of the flammability properties in this table, we are comparing some common refrigerants like propane, ammonia, or, for example, XL20. In this case, you can see that if we start comparing the LFL, which is the lower flammability limit, it means the lower concentration range over which a flammable mixture can be ignited. You can see that comparing, for example, propane, which is an A3, and XL20, which is an A12, you can see there's a difference of 5 times bigger for propane. While if we move down to the minimum ignition energy, in this case, we can have values comparing XL20 and propane, for example, of 2000 times higher for propane, 0.25 comparing to values between 300 and 1000. If we move down again to the burning velocity, which is the speed at which a flame will propagate, you can see here a very, very big difference. For example, an A12 like XL20 is burning with a velocity of 1.6 centimeter per second, while propane with 46 centimeter per second. It means half, more or less half a meter per second. And at least at the end, the heat of combustion, which is the amount of energy released when a substance is burned. In this case, you can see that, for example, Opteon XL20 in comparison with propane is has a heat of combustion 5 times more or less less than propane. What does it mean? So we were speaking about safety risk mitigation because A12 refrigerants are, as you saw from the table, much safer and show safer flammability properties in comparison to A3 alternatives, which are highly flammable, such as propane. So we saw the characteristic of the A2Ls, that they are less likely to form flammable concentrations in the air due to the lower LFL. And this enables larger charge sizes in the systems and larger application ranges. Another important characteristic we saw is that A2Ls are much harder to ignite, so much energy is needed to ignite the refrigerant, making them very safe even to use with the commonly used electrical components. Just to give you an example of a static discharge or a simple spark, which is about 20 millijoule, this could immediately result in ignition of an A3 refrigerant, because it's already 100 times higher than the minimum ignition energy for propane, for example. And A2Ls, as a last but not last important characteristic, are less reactive and have a lower combustion energy. So they can generate milder ignition events, and the burning velocity could be up to 30 times slower compared to A3 alternatives. So as a result, as a resume, A2Ls are a real safe choice to use in refrigeration systems. To sum the three most important characteristics, you need 4 times more A2L to form a flammable mixture in the air, while 2,000 times more energy is typically needed to ignite A2L refrigerants, and more or less almost 5 times lower combustion energy to ignite A2Ls when they are ignited. Sorry. Going deep inside the EN 378 regulation, I'm going to show you here some examples and taken from the Gazzetta Ufficiale della Repubblica, where A2Ls have already been published and released for use in new systems in commercial refrigeration. They are allowed to be used following this standard. While in the bottom part, you can see that there's a comparison showing the maximum charge in systems between A2Ls, showed in green, such as XL41 and XL20 on the right, compared to propane, which are A3 alternatives in red. You can see there's a huge difference between the maximum charge allowed in the systems. But how can we calculate the maximum charge? In the EN 378, there's a specific section related to the flammability class A2L, where you should enter, depending on the access category of the system and the location classification, then you calculate the maximum charge allowed with the formula. It's important here to state that in the bottom part, you see there's no charge restriction for the typical industrial environment where there's less than 1 person per 10 square meters. So this is important to understand. But in order to simplify this calculation, as Chemours, we are providing you a new tool that we developed. It's a free tool, so you can access freely to this new calculator, which is the refrigerant charge size calculator. So it's very easy to use, because you can just need to put the location classification, the access category, the refrigerant you want to use between XL10, XL20, XL40, and XL41, then the room dimension in the volume of the room dimension, and then you automatically can calculate the maximum charge allowed following the EN 378, depending on the safety measures that you are using. And you can see in this screenshot of an example of use of XL20 that the maximum charge allowed for each system is 57.13 kilograms. It means that it's not the maximum charge you can install, but it's the maximum charge per system. Then you can use several systems to reach the cooling capacity needed. The title of the presentation was related to the main differentiating factors. We spoke about one of the most important, which is the safety risk comparing A2Ls versus A3s, but there are also other factors, very important factors, that you need to consider, for example, when deciding which alternatives to use in commercial refrigeration, which are the economical and the environmental efficiency. So a retailer, when he needs to change, for example, from an old installation with running, for example, with 404A to new alternative technologies, must have some criteria to take into consideration, which is matching the cooling performance of the old system, match or exceed the energy performance, match the uptime of the system, match and possibly improve the total cost of ownership, and ideally match the facility and ease of installation and maintenance. Well, as you probably saw in other white papers that we already presented in past webinars, the results of experimental study conducted by an independent consultant called WAVE for a very important retailer chain in the UK, which name is Asda, and probably you all know. The results of this study showed that Opteon XL20 and Opteon XL40 are the best alternative technologies with very low GWP in comparison with the old alternatives like 404A, but also compared to new alternatives like CO2 different technologies. In this case, the results were corroborating all the decision criteria that the retailer needs to take. So it means these are matching the cooling performance, exceed the energy performance, they match the system uptime, the total cost of ownership, and this is very important, the ease of installation and maintenance, because it's a system running, it's a direct expansion system running with this new A2L refrigerant. So everyone is already used to work with this kind of system, like an old 404A alternative. In addition, these two alternatives showed that they can reduce the total CO2 emissions by up to 20% in comparison with other CO2 technologies, but with the lowest life cycle and the lowest CO2 abatement cost. So they were matching all the decision criteria that the retailer needs to take into consideration. But in order to corroborate all these experimental data, I would like to introduce now all the successful applications that we reached in this year with the use of new A2L refrigerants. You can see here, for example, starting from September 2017, in a cold store that started using XL40, then some retailers in the UK, like the Asda case that I already presented you in past webinars, starting running from October 2019, and the England Co-op as well in the same month running with XL20. Then some other options in cold stores like in France, starting running from September 2019, and the Axima case starting running in June 2020. And the last achievement we made right this month in October with the first A2L supermarket in Spain, running with XL20. Starting from this real case, which is a retail store running in Barcelona, the total charge of Opteon XL20 was of 50 kilograms, the shop surface of 600 square meters, and the total cooling capacity of 40 kilowatts, including MT and LT. The condensing units were from Gruppo Disco, 2 condensing units with Emerson compressors, and 20 kilowatts each. The display cases were from Cosca, which is a well-known Spanish OEM, and the control units and the expansion valves were coming from Danfoss. You see here the link to the publication if you need further details for this particular retail store, which is already running from this month. Then moving, for example, to the Co-op store in UK, this is using 30 kilograms of Opteon XL20 with a total shop surface of 400 square meters and the cooling capacity of 12 kilowatts in MT and 3 kilowatts in LT, while they use in MT Scroll Emerson compressors, while in LT Bitzer semi-hermetic. The cabinets are from Pure Cold. The project has been done with Space Engineering. The installer was Oak Refrigeration, and the risk analysis has been made with Cool Concerns. Here as well, you have the link to the publication. And to the end, the example of a cold store, the Technofrabeger example in France, with a cold room of 400 square meters, 2 systems for LT, with a total cooling capacity of 50 kilowatts. The refrigerant is XL20, and the charge is 36 kilograms per circuit. There's also a pre-chamber for with the system running on MT, with a total cooling capacity of 10 kilowatts. The refrigerant is Opteon XL10 in this case, and the total charge is 11 kilograms. It's important here to underline that we also use the heat recovery system installed in parallel to condenser in order to optimize the energy consumption of the whole system. So in this case, the recovered energy is used to heat the floor for the hot sanitary water and for the heat of the employees' rooms. In this case, the A12 components used for the LT and MT systems were compressors from Bitzer, then evaporators from Gunther, electronic valves coming from Carrel, and the risk analysis has been made through Semafroid in France. So thank you very much for your participation, and I invite you to click on the below link if you want to receive periodical Chemours communication and our periodical bulletins. So thanks again, and now I'll open the line to your questions. Thanks.
Thank you very much, Ernesto. It was very interesting presentation and very concrete with the right examples. Silvia, I think we have some questions for Ernesto, do we?
Indeed. So let me start with the first one, which is really interesting. It's from Pier Giorgio. He's asking, what is the maximum amount of R32 gas accepted in a split to be installed in a hospital? So a very actual question.
Yeah, in this case, you should enter the table that I presented you for the EN378, and we'll need to check the room dimension, where the split is placed, if on the floor, the height of the split. So there are many factors that you need to consider. Then you just enter inside the table, and then you can calculate it. But there are a lot of factors that you need to take into consideration to calculate the maximum charge allowed for R32.
If you allow me, there is also an app. There is the Area app you can see on the screen. You can download on your mobile to do all this calculation, as Ernesto said.
Okay, so in any case, you gave some general explanation, so thank you for the
you need to consider the layout where the split
sure.
needs to be installed. So we cannot just say an amount right now. So you need to have all the details of the installation.
Sure. So if I may, I will go with the second question from Khaled. He is asking, what equipment tools can be used with A2L refrigerants? I have purchased new equipment last month.
So I think you mean regarding the systems to be installed. For sure, you need to use A2L approved components. In this case, we showed you in the presentation real case studies where we have different components like evaporators, electronic valves coming from different OEMs.
You mean tools like a recovery machine, something I presented, I think, in my presentation. The tools to do servicing.
Okay, yeah, okay. So you need for sure leak detectors approved for A2Ls in order to start the maintenance of the systems, and the ones that you showed you before. So there are already approved A2L components that you need to use, as the previous one that you were already using doing your actual maintenance, for example, on 404A, because it's a direct expansion system, so no major differences, but the same components needs to be endorsed and approved for A12s. So they need, for example, in the leak detector case, you need to have an approved A12 detector. For example, for commercial refrigeration installation, you need to have it approved to recover and analyze at least, for example, 454C in this case. But depending on the kind of system that you are going to maintenance. So yeah. But anyway, in the market and in the general catalog of producers of these special equipments, there are already plenty of them already approved for A12s.
Thank you, Ernesto. You mentioned 454C, and I have a question in this regard. Can R454C be used in any system, or should I change the safety device like pressure switch, electrical switches, compressor, special, or anything? And this one is from Rolf.
Yeah, as I was starting to explain before, the components that should be installed in new system running with A12s needs to be A12 approved. So all the major OEMs right now have already endorsed these components in their catalogs, as I was showing in the presentation. There are, for example, electronic valves from Danfoss, from Carrel, they are already available. So in this case, for sure, you need to have these components approved for A12. So you cannot have a direct retrofit with the old components you were using in the systems. Even for the evaporators, the condensers, all these components need to be approved for A12s.
That's
clear.
Thank
you, Ernesto. This was the last one for the moment. I think we can give a floor to Paolo now. We have 80 participants, 80 persons waiting for the next presentation. So thank you very much, Ernesto. See you in a bit for the debate. Yeah, for the debate. Thank you. So thanks. Paolo now should become online. Yes, I will give the floor to Paolo. Let me see if we can see his screen. Let's see. Paolo, you should have received. Yes, we see Errecom. Ciao, Paolo. Thank you, Paolo.
Thank you, too. Thank you to all, and I hope there is something interesting in our presentation for our person.
I'm sure.
Now with us. And I can just start? Or,
yes, please. Thank you, Paolo. Okay. The floor is yours.
Okay. I see only my face. I don't think it's.
Yes, we can see it. Okay. We can see it very well.
Perfect. Okay. I'm from R&D of Errecom, and we working on all the product you can need to maintain your system in efficiency, not refrigerant gas, but lubricant and additives and other chemical product you can need to your system. Errecom started its work in 2001 and developed many kind of synthetic lubricant and additive to the market of refrigeration and HVAC and automotive HVAC. We work with 130 countries and have different company in different places. What happened in our business in the last year? The performance was most important than in the past, and what we have to expect for the future in our business. The refrigerant gas was changed, and we must have attention to the pollution, to the world, the gas must be more biodegradable, and we need to use renewable resource to have a new refrigerant. We have to use a minimum quantity of energy to obtain the same condition in the ambient, and we have to maximize the performance of the system. Of course, is the target of every kind of new study. But this kind of changing make other change. More biodegradable products are less stable than the old one, have different kind of problems inside of the system. What happened? What's need to regulate this kind of necessity? We start to work on the lubricant. The lubricant is not a part you can forget when you study a new system, but is an important part inside of your system, and you have to consider and find the correct one, the best one for the refrigerant and the kind of system you want to use. No more we can use a generic lubricant one. One oil is same to the other. Okay, I need mineral, I need synthetic. The price is not the concept to study a correct application of the lubricant. We need a specific one. If we have an application, if we have a kind of refrigerant, we must search the correct lubricant to have the most important performance, the best performance we can have from this kind of couple. The lubricant we use synthetic and semi-synthetic today because the synthetic one can arrive from the renewable and most ecological material and can be biodegradable. The mineral one can't have this kind of capacity. And the best performance we have with a new kind of refrigerant we have with a synthetic one lubricant. For the new refrigerant, HFO, hydrocarbon, CO2, we must have a correct lubricant one, and the new lubricant was starting for specific application. In Errecom, we prepared a new kind of packs for hydrocarbon market, especially for L600, L219 series, but not only for this one. This one is most frequently asking. POE for CO2 and PAG for CO2, because CO2 need for different application can select use of the polyoil ester or polyalkylene glycol, depend of the type of application, the type of temperature you need to work, the type of compressor. Every kind of system can need one or the other, and in this case it's important understand the POE for CO2 cannot mixing with the PAG for CO2. It's two lubricants perfectly work with CO2, but not mixable one to the other. It's not exchanging from one and the other. It's two different products you have to use in different application for your kind of system. And of course, new packs and new POE for HFO for the new refrigerant gas proposed in the market. In this presentation, I want to stay in PAG, speaking in particular for the hydrocarbon refrigeration. Why the PAG was the right selection for this kind of system, and why in the past this kind of lubricant is not selected for this kind of technical. IV viscosity index, the PAG, the polyethylene glycol, have a high viscosity index. When the temperature of working of the system growing, the PAG can resist to this kind of change, not lose his viscosity, and the protection of the part in moving of the system was fully maintenance in the time. Best solubility or correct solubility when you apply with R600 and R290 and the other hydrocarbons. The solubility of ethylene glycol was lower in mixing with this kind of hydrocarbon, and for the measure of application is the best solution to your kind of system. And of course, for the correct solubility, we have a reduction of the sluggings, the phenomenon of moving a ball of lubricant around in your system, and the problem we have when we have a lot of lubricant around in the system and not in the compressor. Our polyethylene glycol have high chemical stability and resistance of oxidation. The material putting inside of the lubricant, the additive we can use, go to maximize the performance of our lubricant. The PAX was that was very using in the past because have difficult to found viscosity under the 3246 ISO, and this was a historical problem. But today we have a lot of system with hydrocarbon that need very high viscosity, like 100 or 150 or more. For this condition, we can use PAX with all the advantages in this kind of lubricant with this new system to refrigeration. And recently, we start to develop a new ISO 85 in PAX for some application with two producer of compressor in Italy. And this is a new proposal we go to present. Not only the lubricant was the correct attention we have to have to the system, but the additivation of the system was very important. The lubricant is not the pure base of the ester or the glycol, but the lubricant finally was a mixing of many chemical products. Many producers of the system say, oh, no, I don't want additive inside of my system, but lubricant was a mixing of additive. There is not today a lubricant was a pure ester molecular or mineral molecular. The lubricant was a mixing, was a mixing or anti-corrosive, antioxidant, anti-foaming. You have to improve the capacity of lubricity of your lubricants inside of the system for any kind of refrigerant you have in your market and you have in your system. The lubricant was a complex mixing, and we studied the correct solution for every kind of mix. Quindi, the additive was based to guarantee the correct functionality of your lubricants, and you have to select a correct additive and correct quality of your lubricants. Now I want to show our additives. The new 1 series is a series dedicated for the application with hydrocarbon in small refrigeration with the compressor hermetic, then use L600 series or L218 or 134A2. We have not only this kind of additive. This is an example for this kind of application, and this new series was a child of the original series we have in the market for the application with normal refrigerant like AFC or FO. The additive was studied for don't change the lubricant status, don't change the lubricant characteristics, maintain high lubricating capacity of the system, high lubricant viscosity have not to change, and there is not the change of the lubricant color in this application. In the other application, there is inside some color to put clear, you have put inside of the system an additive. In this case, we have selected don't have to change the color of the system. The first one was a super dry ultra that was removing moisture, removing water from the system by one reaction. Don't produce solid, but produce a new lubricant molecule. The reaction from water and the additive inside of this product have a generation of a new lubricant and don't change the characteristic, the whole lubricant inside of the system. And important for this kind of product, don't produce solid. There is a lot of chemistry to remove inside of the system some moisture, water, but a lot of chemistry in reaction with the water product solid. For the system was a very big problem. This kind of product not have this kind of problem, product lubricant. And every part of the system can find the moisture, because you know you have the filter for the moisture, but the filter was static, is only in the part of your refrigerant system. The additive can travel around in the system with refrigerant gas and can find the humidity, the moisture in every part of the system. If the moisture was stopping, I don't know, in the exchanger or in the sound valve, and can have a reaction in this kind of area, and have no problem with the hydrostatic filter, of course. No acid ultrawide is the second one, and is neutralizing free acidity inside of the system. There is a reaction of elimination of acidity inside of the system, because if we permit the acidity inside of the system, this kind of acidity can be a catalytic one, can be start a new formation of acidity. We have to stop it and have no more possibility to produce a new acidity one. Eliminate the free positive charge. The acidity was normally in chemistry considered the presence of free acidity was charge positive, and the system go to remove from the system. I don't know why. Start to open it and passivate the metal of the pipe and of the exchanger of the compressor for prevent a new possible corrosive attack on the metal. Cool-Shot Ultra White was a special additive to remove the deposit of the lubricant and the waxes inside of the pipe and the exchanger. When we have oil fouling in our system, some of lubricant remain inside of the system, stay in the exchanger, and in the time go to reduce the exchange capacity of the system and the power of the system. This kind of product take this wax, this oil, and make this one come back to the compressor. In the second step, the product make a protection on the pipeline and exchange line to the new deposit of the lubricant in the pipe, and maintain in the time the correct performance of your system, and restore, of course, efficiency of initial system condition. This product cannot make a more powerful than when the system was new, but replace the performance than the system was new after many hours of work, when you have a lot of oil fouling, a lot of deposit of lubricant inside of the system. Extreme was our most important product. This is a leak stop. Permanently seals the leaks, the micro leaks inside of your system. When you have some leaks, you can find it because it's so much small, because you don't lose your charge of refrigerant in 1 day or 1 week. You lose during the month. You know there is a leak, but you can find it with electronic noise. You can find it with tracer or other system, but you know there is. The micro leak system to close is Extreme Ultra. Extreme Ultra traveling in the system, no have chemical reaction, no react with moisture, no react with oxygen. This kind of products is polymer free. There is not the oldest leak stop in the market, then block your extraction valve or destroy your system. There is any kind of chemical reaction inside of your system. You can use like a prevention, because it's like blood of the person traveling in the system, and only when there is a leak, they go inside of the leakage and block, stop it with a physical barrier, not with a chemical reaction, and was permanently change his condition only with the change of temperature, during the work moment and the stop moment. It's a little bit more slow than a polymeric one, but ever problem free. Only the solution and not the problem of the reaction and polymer product. Why we call ultra? Because we have just in the market normal series of this kind of additive, but our study was to reduce the ratio of additive needed in the system from 1 to 125 part of the lubricant in the system, 1 part of the additive, and for 125 of the lubricant. And this not change the level of lubricant inside of your system. Of course, is very small one quantity, and you can put inside of your system all the additive if you want, or select which one additive you need. Because if we are arrived to the leakage, it's possible we have a corrosion. If we have a corrosion, we have probably the acidity. We can put inside no acid to remove acidity, and extreme to close the leakage. It's not correct only closing the leakage if we don't have a solution to the perimeter part, to the removing acidity or removing moisture, then can have generate the acidity, then can have make aggression on the metal. And this is all. I hope to be
You were perfect.
And,
you were perfect.
Thank you very much for your attention.
You were perfect in the timing, exactly 20 minutes for your time, and we have still 80 persons waiting for you and listening to you, and we have very good questions, to be honest. So Silvia can give you the question. We have very good question for you.
Sure, with pleasure. So let me start with the first one from Daniele. Could we use Cool Shot Ultra also to wash the system? Is this additive then easy to remove from the system?
No, Cool Shot was only to use like additive. It's not a method to wash. Cool Shot traveling in the system, carrying from refrigerant gas. It need the system was in working, and need to exchange its chemistry, then the chemistry of the lubricant, the box in stopping in the pipes. For this reason, Cool Shot must work with the system working.
Okay, so not to wash. Okay.
It's not a wash system. It was a catalytic system, then work with the refrigerant, and the lubricant can travel inside of the system and must work for a year. When you put inside, it starts to work and working when you change the oil, you remove the additive. But if you don't change the oil, the Cool Shot working every day. It's continually.
Okay.
Not
a washing system.
So I will go with the second question from Felix. It's both a question and a comment. So he's asking if the compressors OEM tested and qualified this product, because some of them say that the external product found inside the refrigeration circuit remove any guarantee of the compressor.
This is important discussion. Is a part difficult to say, because many of our additive is just inside of our lubricant, and our lubricant is approved for many OEM producer of compressor, and was approved for a producer of valve and exchanger. But when we say, okay, the protection of acidity inside of the lubricant, how work? when there is acidity, there is a reaction with no acidity present in the lubricant, and there is a consume of this kind of additive inside of the lubricant. When this additive finish, the system start to grow in acidity. We take another quantity of the additive just present in the oil and put inside of the system, and go to replace a start condition of the oil. You know, I don't put an anti-acid different from the anti-acid just present in the oil. I put the same one. And why you producer of compressor don't want we put inside the same additive you just approve in the oil you use in your compressor? But some producer of compressors say, no, I prefer there is no put inside additive. Normally, you need additive after 2-3 years, and a compressor guarantee was finished, because normally you start to have corrosion, you start to have a problem of moisture, you start to have a problem of oil fouling after 2 years, 3 years.
Yes,
and
so after the guarantee of the compressor
was finished. And in this case, you can start to use
the additives.
The
I think
additive.
it's a good solution for late life of the components and of the systems. Okay, thank you very much. I think this is all for Paolo. Now we have a final debate, right, Silvia?
Yeah.
So I call Ernesto, and you can stay here, Silvia, with me. We have a couple of questions that are general. I have a very general one. We have still 70 persons with us. Thank you for all the 70 persons that are here at the end. We are a bit long with the webinar, but are very interesting subjects and topics. The general question I leave for the last question. First, I have some direct question for Ernesto at the moment. I have a question from Franco asking for mobile air conditioning. The 1234YF, he thinks that is a bit problematic above 1000 Celsius if there is a fire, because it develops fluoridic acid. What is the best choice for automobile, for cars? Do you think it's the best choice, even if there is this problem, Ernesto?
Well, actually, this refrigerant has been endorsed globally as the best choice possible for mobile air conditioning in order to replace 134A, which have a higher value of GWP. And in this case, we are speaking about a value of less than 1. So it has been endorsed by all the major manufacturers all around the world, and it's already been used since 2017. So all the new cars coming out from factories starting from 2017 are using this new refrigerant. And of course, I haven't heard about cases of problems related to this kind of issue that we were mentioning here. So at least I don't think it's one of the most relevant problems that you can find with this new refrigerant. In order, it has been chosen in order to lower the global warming of the mobile air conditioning system.
About fluoridic acid. Is fluoridic acid also generated by traditional refrigerants or only by R1234YF?
Well, in this case, there's a debate on TFAs, the temperatures of ignition. So there are studies related to this. So I think I would relate to this, but since it's approved and endorsed and homologated by everyone, I don't think this is a relevant topic to discuss on this refrigerant. it need to be used or not, or to be changed in favor of other ones. So
okay. I have a common question for both of you from Marco. Is it possible to retrofit existing installation with A2L refrigerants? And can I change with the same lubricants? Is saying later another participants. So the question is, it is possible to retrofit existing installation with A2L refrigerants? This is for Ernesto, the first part.
Yeah, so as I said in the presentation, it's not possible to retrofit directly an existing installation with A2L. Anyway, if you consider the components, since it's a direct expansion system, the components are the one commonly used for A1. You just need to have an A2L homologation for these new components. I'm speaking about compressor, evaporators, condensers, and electronic valves. So, but most of the OEMs are already introducing these components, already endorsed for A2Ls in their catalog. So there's no major issue. Even if, of course, it's not recommended, but if you directly change from an A1 old refrigerant to an A2L, the system will work. In any case, we are not recommending this because the system will be not homologated to work with this new refrigerant, but the system will work. Since A2L components are very similar to
what about
to
the lubricants, Paolo? We need to put the same lubricants, or we can change lubricants if we change the refrigerant?
You must change. You must change. You have to select a correct lubricant for the new one refrigerant. It's very important to put a correct lubricant for every family of refrigerant.
But if I think the participant is asking, if I change the refrigerant from an existing system, can I use the same? I have to use the same oil, or I can change the oil, a different kind of oil?
It's possible you have to change the kind of oil, because the oil was most important for the kind of refrigerant and the temperature and the condition to work of the system. For the system, you have to maintain a correct capacity of lubricity, the viscosity. I don't know. If you change from the one system, I go to very simple. Have a mineral ISO 68, and you put a new refrigerant who need ester, I don't know, POE. It's possible to have to wash, change the mechanical part, need a new one condition correct for the refrigerant, and you can use POE for this kind of refrigerant, probably 68 like a mineral, with the same capacity of lubricity, viscosity, but more specific for the refrigerant. Say very simple, depend the kind of refrigerant, how changing the viscosity of the oil. But normally, when you have make this kind of change, you have to change for sure the oil, and not can use the whole quality of oil.
Okay. One more question for Ernesto, then I want to give you a final question that I have for both of you. But the direct question for Ernesto is the path to reduce the GWP. Is necessary to go through A2L, or there are still A1 solutions? I think it's really an important question and a very difficult answer.
Yeah, it's a very interesting one. For sure, on A1s, there are some alternatives with a lower GWP compared to the one that had been used so far. But with A2Ls, of course, you see that the values of GWP is much lower. So if you want to focus on GWP only, which is not the only factor you need to take into consideration, for sure, we think as Chemours that this is the path, a long-term path. But of course, as I was mentioning in the presentation, there is also the energy consumption of the system. So with the A12s, we showed you some real examples after the experimental data that the energy efficiency of the system is better and comparable and better compared to the old A1 alternatives. So we not just have to consider the GWP in order to be environmental friendly, but also the energy consumption of the whole system, which with A12s is better than A1's alternatives.
Very good. So my final question for both of you is this one. We come back to the title of a presentation. I also want to maybe share my screen if we are here, so we can do a final all together. So my question is, coming back to the title, chemistry for safety in refrigeration. So I start with Paolo. So chemistry is important for the safety in refrigeration, both considering the well operation of the system and the safety of the people that use the system. So I don't know if you understand, both the safety of the working of the system, the proper working of the system, both, and the safety of who is using the system. Is chemistry important for that?
Yeah, for sure. The chemistry was the base inside of the system. The technician have not forget the refrigerant gas was a chemical molecular. The lubricant was a chemical molecular. And if you know what they do in the system, you can maximize the condition of the system and reduce the risk of leakage, and every kind can appear when something happens outside of the system.
Okay, so you think it's useful for the safety of the system and who is using the system?
For the operator, yes.
Operator, yes. Ernesto?
Yeah, I can just confirm what Paolo said, because as I presented in the table, if you know these, for example, A12 refrigerants, how they work, their flammability properties, then you know how the system works, and in the case of leakages, you know how to act. So I think chemistry is at the base, it's fundamental even for the operators. Yeah, you should know how the system is working and with kind of components is working. So even
the operator doesn't know about it, of course. Yeah, the operator is just using the system, so it's even worse. You know, it's even more important. But even if the operator doesn't know anything about refrigeration, you need to be safe. So he needs something he can trust to be safe, the operator.
Sure. And for example, for the new A12 systems, with all the certifications that they need to have, you see that the system is even approved for eventual leakages. So you have ventilation, additional ventilation, so you cannot form mixtures in the air that could result in an ignition. So even if the operator doesn't know how it works, the system should be proof for this kind of possible accident that should not happen.
Exactly. So you come back to my presentation at the beginning, that it's important that few but important rules are met. So the operator, the technicians, the constructor should stick to these rules of ventilation, of increasing ventilation, increasing safety, precautions, and competent persons. Okay, I think we are out of time. We are 12:20. I would like to thank you, and please, your last word for the audience. What do you want to say to the audience? Paolo, do you want to say something to the audience? Thanks to the audience.
Only thank you for attention, and make attention on the lubricant and on with every chemical part you use in your system. It's important to understand and make correct mantention and select product from the
right sources, the right sources.
With a correct reference.
Yes, right sources, reliability of sources.
Yeah. Don't use refrigerant gas from you don't know provenience. Don't use lubricant from you don't know provenance, because you can have in your system
the same for illegal gases, Ernesto. The same problem we have for illegal gases. Only we should know the sources of the gases. Yes, Ernesto?
Yes, correct. We need to fight the illegals for sure with our utmost effort, especially now next year in 2021 with the next quota reduction. And we need to tackle this, and we are tackling this as Chemours, as the FCTCs, or with the associations. We are trying to fight this also area. Yeah. So everyone is involved in that, and we are ready to support even with the investments on this, because we need to fight it if we want to reach the climate neutrality in 2050, which is one of the most important objectives of the EU.
So Silvia, do you want to say last few words before we close?
I want to thank everybody, yourself, the speakers, and our attendants for the attention for this webinar. And of course, you will receive the recording and the material that was presented in an email in a very few days. And just keep in touch with us, because a few more interesting news will come. Thank you all.
Thank you. Take care.
Thank you very much. Thanks for participating.
Bye-bye, everybody.